So if I do an ls-la, you can see that I get a list of all the files that are here. And actually, let's go ahead and compile hello.c. So yeah, now we have that executable file as well. And let's make a directory. Okay, so we have an executable file, we have a directory, and then we have some assorted ASCII text files. Now, you get a lot of information with ls-l. You get the file name in this last column. It also gives you the date that the file was last updated. You get the size of the file in bytes. And then these two columns tell the owner of the file and the group owner of the file. And in Linux, you actually get a group that's your own by default as your primary group. But suppose you worked in a large corporation, maybe they would want everybody in the C programming group to be in a group so that you could create a file, change the group ownership of it, and then everybody in that group would have certain permissions. And we'll talk about those in a minute. This column we'll talk about later, but it's just to indicate how many links there are to a file. And then what we're going to be interested in today is this list of, I believe it's 11 columns. Yeah. And specifically, we're going to focus on these middle 9. We'll go over the first and last later. The first is just the file type, so you can kind of see that the directory has a D in that column, and the regular files just have a dash. But what we're going to focus on specifically now are these 9 columns. And we can actually break that up a little bit. So we have 3 octals. Okay, so if we have these octal numbers, this is a 1-bit, a 2-bit, and a 4-bit. So this could represent the numbers from 0 to 7. And this first set of 3 is going to be the owner's permissions, then the group's permissions, and then finally global permissions, what permissions everybody has. And you'll notice there's 3 different permissions: read, write, and execute. So the owner of this file can read it and write it, but not execute it. Anybody in the same group as this file can read and write it, but not execute it. And anybody who wants to, or anybody in the world who has access to this file system can read it, but they're not able to write it. They're not able to make changes. If you want to know what groups you're in, there's a groups command. And in our case, I'm only going to be in 2 groups. Wait, here with the primary group. And wheel is pretty commonly used in Linux distributions. You can create groups if you want. I'm the only person who uses this particular VM, so it doesn't make a lot of sense. But of course, if it was a system where multiple users were sharing a system, then you might want to do different groups so that you can assign permissions to things based on group rather than each individual user. So you can say, hey, everybody in the CSC 220 group has access to these files. And if you're in the CSC 240 group, then you have different set of access. If I want to change permissions, there's a couple ways to do that, but primarily you're going to use the chmod command, or chmod, you'll sometimes see it called. You're going to give it 1 octal digit for each set of 3. So this would be 6, 6, and then this would be 4. So 664 would be those permissions. And now I'm going to change it to 660 on class.text. I'm going to change it to 600 on hello.c. I'm going to change it to 644 on schedule.text. And if I do an ls-l now, you'll see that 6 is for class.text, 6 is the user permission, so that's read write. 6 is the group permission, so that's read write, not execute. And then no permissions for the global user. Hello, we have 600, which is 6 for the user, 0 for the group and for everybody. And then for schedule, we have 644. So 6, that means there's read permissions for the owner, and then 4 is just that one bit is set. Again, remember we have these 3 bits, so that's just this bit. So read is on, write and execute are off. Now suppose I want to create a simple shell script. Just say echo hello world. So now if I do ls-l, you can see that that script has 6, 6, 4 as its permissions. So that's read write for me, read write for group, read for everybody. But I want everybody to be able to execute this. So I'll do chmod 7, 7, and then this is 4, 0 for 2, and then the 1 bit. So that would be 5 for the global user. And if I do ls-l, I have execute permissions. So if I run thing.sh, you can see that that's there. If you're wondering how these permissions get created, if I touch, let's say test.txt. So test.txt has 664 as the parameters. Well, if I do umask, that gives me the mask that gets applied as things get created. Okay, so with the umask, this is the file creation mask. So the default for directories is 777. So here you would have read, write, execute for the user or the owner, the group, and globally. However, obviously that's a bad thing. You don't want every file by default to have full permissions to all users. So we use the umask to turn bits off in there. And we're going to be concerned with these last 3 bits. The first bit is used to set some other settings like the sticky bit, which we may get into later if we have time. But the focus we're going to look on is here. So this tells us 0 bits for the user, take away 0 bits for the group, and take away the write permissions for the global user. Now, you may ask, well, when I do touch test.txt, it looks like that none of them had execute permissions either, even though none of these turn off that execute bit. So what's happening there is the default permissions for a file are 666. Read write, read write, read write, no execute anywhere, because by default you don't want to execute a file. And the reason is that file could be text with some commands or something, and you don't want those to by default be executable. So directories have 777 as their default parameter or their default permissions, and so that's why you'll see that essentially all this is doing is turning off the global write bit for whatever the default permissions are. And if that's not making sense, let's do a quick example with VI. These permissions, let's say they're 6, 6, and 4. So that's an octal 110, 110, 11, or 100. Now the way that gets set, or actually the way to think of this is, if you add the map, when you first create a file, let's say the default permissions are 6, 6, 6, which is 110, 110, 110. Well, the umask that we see here is 0, 0, 0, 1, 0, which is 2. Right, so we have 0, 0, and 2. So you can almost think of it as subtracting. So we get 110, 110, and 100, which is 664 for our actual file permissions. And something similar would happen for directories because they typically have a default of 7, 111, 111, 111, So the default umask is 0000002, 020, I should say. I'm sorry, 010, and that's 002. And so that gives us, for a directory, read, write, execute for the owner, read, write, execute for the group, and read, execute for global users. Hopefully that makes sense what's going on there. You kind of have to get used to playing with octal, and that just makes this a lot easier. There is a way to specify, I want to add write permission for the group, or I want to take away execute permission for the owner. But I think in the end, those get complicated. It's actually, in my opinion, worth it just to spend time getting used to what's going on with octal so that you understand what those permissions do. One other thing with permissions, there is a global user called the root user, and I can change to that user using the su command. Okay, so now I'm the root user. If I touch a file and do an ls-l, you can see now that I own it, the root group uses it, and notice that the umask here is 022 because I don't want any other user by default to be able to change a file that the root user creates. So you can read it, but you can't write it. I can also use the sudo command if I'm a sudo user, which hopefully I am. Actually, I'll call this sudo file. It's going to ask for my password. And if I do an ls-l, notice sudo file was also created with root. Sudo runs a command as the root user, meaning you have that user's permissions. And you'll notice it used the same umask that it used there. Even though my umask is 0002, it's still, when it created the file, it used the root user's umask because when you run sudo, you're running it as the root user. Okay, so su is the switch user command. So I switched to root, but I could have switched to any other user on the system. And sudo is the command to run as the root user.